So we're continuing lesson 5 here. We're only going to have really about time for a problem and a half. But our first problem is simplify this. And it's a to the power of x over 2 times the quantity of y to the 2 minus x power. And that quantity is raised to the 1/2 power. All over a to the 3x times y to the negative 2x power. So when I look at this problem, I actually see a couple things going on. Does anybody have an idea or something that they want to do first? Because there's about 2 different approaches I think we can handle here, maybe 3 overall, that I could do first. Seeing some things that we like, maybe some things we don't like, some things that we see, hey, maybe we can do this. Nothing. Take a look. I have a's on top, a's on the bottom. So I could do something with those bases. I'm dividing. So I do what the exponents? Subtract them. I also have y's on top and the bottom. I could subtract those too, right? But wait. The top y's have a power of a power going on. And a power of a power I multiply. Can you guys see that? So therefore, I have to multiply that 1/2 in. But wait a minute, the power that's inside the parentheses is 2 minus x. So actually that 1/2 needs to be, starts with a D, distributed in. So I'd have to do this. So if I decide to do 2 things at once, means deal with the a's and then deal with that expansion of power of power, what would it look like? It'd be a, what do I do when I divide bases? I do what to exponents? No, I subtract them. So it's a over 2 minus, what? What's the exponent on the bottom? 3x. And then I'll have y to the, what do we get when I distribute that? 1/2 times 2? 1 minus 1/2 x, or x over 2. The a from the bottom came to the top there, that's why it's the minus 3x as an exponent, which leaves me with y to the negative 2x. Is everybody okay with that so far?
Yeah, looks great.
Again, 2 separate things are going on. I have some exponents on a that need to have a common denominator, and I have some y's that the bases are divided so I can subtract those exponents. So let's do that. Now, if I'm looking at those a's, what's the common denominator? It's x over 2 minus 3x. So I need to have a 2, right? I need to have a 2 on the bottom. But to get there, I need to multiply the top by 2. So I'm going to have a to the x over 2 minus 2 times 3, 6x over 2. Okay. And the y's. What can I do to their exponents? I'm dividing, so I do what to the exponents? Subtract. So it's 1 minus x over 2 minus, I'm subtracting what? A negative 2x. But when you subtract a negative,
You actually add and it becomes a positive.
it becomes a positive. So I'm going to change that to plus 2x right away so I don't have to worry about it. If I look at that now, I could put the a exponents together. So I would end up with a to the x minus 6x is negative 5x all over 2 because of common denominator. And now, if I actually think about it, I need to have common denominators on the y's. Take it one step at a time. I'm not doing all of it at once. What's the common denominator between all three of those? It's 2 again. So I think everybody would agree that I have to multiply by 2 over 2. And I have to multiply by 2 over 2 for the 2x, yes? Yeah. I'm just going to rewrite that. So that becomes y to the 2 over 2 minus x over 2 plus what? 4x over 2. Wait. That a has a negative exponent. Do I like it? No. So where does that exponent or that a value or a base need to go? To the bottom, and it becomes positive 5x over 2. I like that. And now I have a common denominator for my y's, so we know it's all going to be over 2. What's the top look like? What's 2 minus x plus 4x? It's 2 plus 3x. The negative x and 4x make a 3x. But I'm going to switch it.
What?
To 3x plus 2. Does that make a difference? No, but it's putting that into kind of standard form. And that's what I like to see. I'm going to say that this is done. Everything's simplified, right? I got no negative exponents, so I'm not taking the top to the bottom or anything like that. There's my answer. Problem here, problem 3. Problem 3, guys, highlights when we went over those 7 exponent rules, and I gave you that problem of like 2 plus x to the negative 3 all over h. And then we talked about how you cannot bring it to the bottom and cozy it up with the h. Remember back there a couple days ago. Because there was the plus or the minus sign there. Same thing here. I get x to the negative 2 plus y to the negative 2. And it's over xy to the negative 1. They each and every one of these has a negative exponent. So many of us want to take the top and move it to the bottom, and the bottom to the top, and call it a day. But you can't because of that plus sign. They're not all multiplied and divided. And so each one, I say, goes to its own basement. It goes to its own bottom. Which means your first step is to make positive exponents. And so, that's what it looks like. Can everybody agree with this? If they all went to their own basement, you would have that. Now, to handle this, there's a couple options. I could get a common denominator between x squared and y squared, put them together, and then I'd have a fraction divided by a fraction, and when I divide by a fraction, I flip and multiply. Takes a little bit of time. There's quite many steps to that. And so, I think of it this way. I'm going to take this problem, and I'm going to find the LCD, or the least common denominator. So, find the LCD, and if I do this, I can multiply it to every term, aka the top and the bottom. And if I multiply it to the top and the bottom, it'll cancel all denominators, getting rid of the fractions, and we're home free. So, what is the LCD? Well, the LCD works this way. You might want to write this down, because I'm not going to write the steps down. Number 1, make sure all the denominators are factored. In our case, x squared and y squared. They're kind of factored already. When you have x squared, you know how many x's do you really have. How many y's do you really have? I have x times x, so it's like an x squared. There's two of them, right?
How many steps are there?
2. After they're factored, you write down the first denominator completely. It has to have the most that every individual has.
Can you repeat that?
Has to have the most that every individual has. Like I have to have x squared.
Think one more back.
Like the first thing you said after you yelled 2.
Yeah. I lost you after 2.
Oh, you said after